ChatGPT, as if Douglas Adams and Marvin had a son. How does it know everything and nothing at the same time? So let's dive into the basics. How do computers think? Imagine we're training a program to tell us what's a cat and what's definitely not a cat. The model learns patterns from the data, spotting those piercing eyes, that judgmental stare with an unmistakable air of superiority, and then labels new data accordingly. It starts making decisions on its own, aka thinking. Well, sort of. So when you send a message to GPT, it uses its big AI brain to predict the most likely response. Okay, but how? I mean, let's start with the very beginning. How do you train an AI model like GPT to predict anything? In the first phase, called pre-training, the model is fed an enormous amount of text. Think billions and billions of words from books, articles, memes, tweets, you name it. This data helps the model learn language patterns, grammar, and vocabulary by predicting the next word in a sentence. Kind of like how a toddler learns language by listening to adults talk, except this toddler has read the entire internet. After the pre-training phase follows the fine-tuning, which is training in a narrower way. The main difference between the two is that fine-tuning uses a smaller dataset that teaches the model how to behave. But what's so special about fine-tuning is that it uses supervised learning, while pre-training uses unsupervised learning. What do I mean by supervised and unsupervised learning? Well, think of unsupervised learning as you trying to juggle with no instructions, just tossing balls in the air and hoping for the best. The model takes a sentence, chops it off at a random point, and tries to predict the next word. If it gets it right, great. If not, it gets a digital slap on the wrist and tries again. It keeps on doing this again and again and again. It is called unsupervised learning because we don't explicitly give it labels for each response it has to generate. With supervised learning, the model is given some training data which contains labels. In the fine-tuning process, which uses supervised learning, the data that's being given to the model includes both the input sequence and the desired output. Okay, but how does the model make a prediction? When I give it some text, how does it actually know what to say? Well, should we even ask, does it understand what we are saying? Well, not exactly. The model doesn't understand words the way we do, it understands tokens. So it breaks down your input into these tokens. Think of them as tiny pieces of language Lego. A token is equal to a word or some characters in the English language, depending on how long is the word and how often is it met in the dataset. Each token has its own vector embedding in a multidimensional space where the vector represents the word's meaning related to the other words. It's just a bunch of numbers that represent the meaning of the word. Okay, Sherlock, but words alone aren't enough for us to be able to represent the meaning of some text. We need to look at the whole phrase and the way in which words are arranged with respect to each other. And that's where the attention mechanism comes into play. We get 2 copies of all the tokens and then we look at the correlation of one token to all the other tokens, and we keep doing that. Now, these correlations have been learned throughout the pre-training process. And at the end of this attention, the initial vector of the token suffers some slight changes, its direction being changed a bit. And after all of this token tinkering, it's time for the AI to actually think. But wait a second, can AI really think? Well, my dear Watson, we can think by using a brain, obviously. And this is an artificial neural network. Now, those vectors we adjusted with the help of the attention mechanism enter the network, get multiplied by weight matrices. Well, think of this as the model's long-term memories about everything, really. They are just a bunch of numbers specific for each layer, and the initial vectors pass through layers upon layers of mathematical operations being multiplied by all of the weights, and along the way functions like ReLU, which stands for rectified linear unit, because why use simple names, decide which neurons to activate and which to silence. Pretty much like your real brain neurons do, actually. Okay, so what does AI do with all this algebra? Well, in the output layer, it generates probabilities for the next token. These probabilities are then used to predict the next word in the sequence. One parameter we tweak here is top P, or nucleus sampling. Fancy term, but it basically limits the list of possible next tokens to those that cumulatively add up to a certain probability which equals that of the value of top P. Now, the model randomly picks from this short list, so it doesn't always choose the most obvious word and sound like a boring know-it-all. And voila! You've generated one token. Now repeat this process hundreds of times and you've got yourself a full-blown response. Okay, this was fun. Wait. So you're telling me that AI takes my text and breaks it into bits, turns those bits into numbers representing meaning, pays attention to certain words over others, runs all that through a complex network of math, generates a list of possible next words, and then randomly picks one? Yup. Couldn't you just say that? Well, now you know.